Okay, I think I once again was just bad at OBS and didn't hit play correctly, but whatever, it's fine. Long story short, we have our input is a list of pairs saying that this number has to appear before that number. So it's a list of ordering constraints, basically. The left-hand column must appear before the right-hand column. And then we have a bunch of arrays of numbers, and we're going to check which arrays of numbers meet the above ordering constraints. So, for example, in this array, it meets the ordering constraints because, say, 75, well, if we have a look at here, the only time we see 75, it's saying it has to be before something. And if 97 is in the input, then it has to be before 75. But we can see that in this input here, 97 is not. So that meets the ordering constraints. Okay. They also need to know the middle page number for each update being printed. You need to find the middle page number of each correctly ordered update. So 61 is the middle here, 53 is the middle here, 29. Okay, don't really know why that's required. Okay, cool. Well, let's see. Let's start coding and see if we can get it. So, first steps first, we're going to grab the input. Include string just kind of compiles the file here into the binary as a static string. So we don't have to worry about doing any file I/O, and that just helps make the code a bit faster if you already know it at compile time, which we do. We're going to get a test module. We're going to get some example code. So I think first we're going to parse out the puzzle. And we're going to take the input, which is a string, and the output is going to be, I guess, let's make a struct for the puzzle input. We're going to have two fields. We're going to have the ordering constraints, which is just going to be, I guess, a list of pairs. I like to make a new type for the numbers because it's never clear to me in advance if they fit in a U32 or a U16 or something. I guess we can just use U32. So the constraints are a list of pairs, and then we have the, what was the term for this thing? The pages to produce in each update. Okay. Let's just call it pages, which is going to be a vec of x. So each page list is a vec of U32. So I guess we can just say like update is a vec of U32s, and then this is going to be a vector of updates. Okay. Cool, so when you parse, you're going to get an input from it, and that'll just be straightforward. We're going to say we're going to have some number of these things, and then there's an empty line, and then some number of these things. So firstly, let's get the two halves. We're going to say constraints updates input.split at, not an index, we're going to split once, that's what we want. It'll be an empty line. And we'll unwrap, because if that's not found, we want to panic. I did get a kind of complaint that there's a lot of unwraps, so I'm going to try just doing question marks here instead, which means I want to add anyhow. It's a great library for just like, there's some error, basically. Use anyhow result. So it means main has to return okay if everything worked out, and then didn't find something, we're going to return upwards. Let me just import the macro. Okay, so now we can return upwards nicely. We've got the constraints, we've got the updates. Now the constraints, we just need to split on every line. Constraints.lines, and that'll give you us an iterator of lines. Then we're gonna, for each line, we're going to say line.split once on that pipe character. And then we'll collect this all into a vec. But this map now returns results. Or, I guess we can do anyhow no pipe found on a constraint line. Okay, and so this is now giving us an iterator over results. But really when we see, this is why I don't really do nice error handling, but I guess the point is to learn Rust here, then we probably should. So this is now giving us basically a vec of results. And really what we want is to make sure that all those results are okay. So we're actually going to collect it into a result of either vec or anyhow errors. And then we're going to use a question mark there to return it upwards. And now this is actually a vec of pairs. And we don't actually want these to be pairs necessarily of strings. We want them to be pairs of numbers. So we're also going to parse each number. Okay, and I think, yeah, cool. Just keeping an eye out for my landlord who's supposed to come by and fix a bunch of stuff. But yeah, okay, let's get the parsing of numbers correct as well. So this line, I'm going to enable hints here. This is now giving us, inside this map, this is going to be a result. And we're going to, if it was okay, we're then going to also try and parse a number from each side. So we're going to do a map where we get, you know, a left number and a right number string, and we're going to say left.parse. Now I'm just going to do an unwrap, right.parse.unwrap. And I'm going to put this in OK. Cool. So now the last thing we have to do here for parsing out the input is to parse out the last bunch of lines, which are going to be the page updates. So let's just do updates dot lines dot map. For each line, we want to split the line on commas. Split on. Oh, just split. Kind of. Oh, we have to collect this. Make it from an iterator into a vec of x. Oh, and it's correctly pointing out that when you split, we're getting a list of strings, and we're going to have a list of a list of numbers. So we're going to do another map here. We're going to say, take, this string, and I'm going to do string.parse. And again, I'm not going to worry about the error handling here. Okay, so this is not correctly parsing our input. So let's just make sure. Let's print it out. Let's take this input and we'll parse it. Let's make this a method, actually, a method of input. I just like the look of that. Input, function parse, and it'll return self. Input equals input parse from this. And we'll just print out the number of, we'll print out the debug. Which means we need to derive debug on this. And then we'll do the same thing for the test input here. So let's say let input equal input parse from the test input, which is okay, sorry. I'm not used to the Mac keyboard apparently. Input parse the test input. And this is a test, so we're just going to unwrap it. Or we could make our test return question mark. Now return a result. And this input, what do we know about this input? It should have a non-zero number of constraints and of 1, 2, 3, 4, 5, 6 things here. So let's just say input.updates.len should be 6. And how many of these do we have? This starts at line 50 and it ends at line 69, so that's 20. So the constraints length should be 20. Okay, let's see. 21. Interesting. Let's just print it out. Make sure we aren't including anything, any empty lines. Okay, cool. I guess I just counted wrong. The constraints look good. And the updates look good too. Okay, and let's run it now. Okay, yep, these, all seem reasonable. I guess just to make sure we parse correctly, we can just add a little assert here. Assert that updates.len, updates.is empty, and neither should constraints be. I really like to use this little, put the not at the end, because I think it looks weird if you have two exclamation marks next to each other like that. So that's fine. I don't know why it needs type annotations now, but whatever. That's fine. And this underscore here just means Rust already knows what the inner type is, so it doesn't need you to put in the inner type here. I could put U32 and make it more accurate. Or, I mean, like a vec of U32. But it doesn't actually need that. All it needs is to know that it's some kind of vec. Okay, cool. So we've got the parsing correct. Now I just need to actually solve it. So Q1 solve Q1 for this input. Okay. And now we'll just make that, make the function here. I guess we could do input.solve q1 instead. Solve q1 will take self, and the answer will ultimately be a u32. Okay, so firstly we're going to filter and find only the updates that actually meet the constraints, and then we're going to add them up. So let's put in the answer that we know from this example here, where it said, how many updates? We have the first update is in the right order. Second and third are also in the right order. Fourth is not, fifth is not, sixth is not. So instead of just doing one big solve function, I want to break this into some smaller parts so we can test it properly. So let's just have, we're going to have like updates in correct order. So we'll return indices to the ones that are correct. And then in the end, we can say input.updates, what was it called? Updates in correct order. And it'll be the back, 1, 2, the first here, yeah. And then the last three are incorrect. Okay, so let's do this part first. What's this error here? Oh, we never actually, we should make sure that's correct. Cool. Okay, nice. Okay, let's find the updates that are correct. So the constraint we're trying to do, the constraint we're trying to solve here is that, like, we get this array of constraints, and they're saying the number on the left must appear before the number on the right. So for every page in the update, we could check that it meets all the constraints, or we could go through each constraint and check that that constraint is correct given the updates. And we could do this kind of brute force in an ON squared way, just, you know, for each constraint, check each update. But I think we could also do the other way, like instead of having an array of updates, just in order, like, you know, what's the sample one? It's, instead of having this and then checking in order, we could map each update to its position. And then we can, for every constraint, we check the left item and the right item. And if the left and right item both exist, we check that their positions are less than each other in the right way. So I think I like that idea. And again, we can kind of break this into a smaller part. Let's just say update is correct. So we're going to check update, you know, update 0, say. So let's firstly make a map for it. So we're going to take self.updates I, and then we're going to iterate over it. I'm going to enumerate, and that'll give us tuples like the index and the page number, and we want to reverse that and get page num index actually I don't think that's hash map from. Let's see, did I get that correct? Cool. Yep, and that gives us hash map. Cool. And this, let me just check my work here. This should be a map from U32s to their index, the U size. What's going on here? Oh, it's giving us reference to U32, which isn't really a big deal. We'll just dereference it. Okay, so now we have a map of page numbers to their position in the update list. And now we're going to check. We're going to go through every constraint and check that the constraints match here. So for constraint in self.constraints, and we're going to exit in that loop. If we find something, if we never exit, then it must be true. So let's see, for constraint in constraints, we're going to check each side. So let page before, page after equal constraint. And we're going to check that if page, well, if this only matters if both the pages and the constraint are in this particular list of updates. Like if you're trying to constrain page 103 and 104, and neither of them appear in the update, then it's fine. It doesn't actually mean anything. So if update, if it doesn't contain page before, or it doesn't contain the page after, then we can just continue. If it does contain them both, then let's make sure they're correct. So then let's say, actually we can do this all in one line. Let's say that position of the left page I don't like this terminology before and after here, actually. Let's do page left and page right. Update, page left, page right, and then we will do if pause left page, we can do a match on them. If they're both sum, then we'll do something. Otherwise, we'll just continue. If they are both sum, cool. If they're both sum and if right is greater than or equal to left, then we've broken the constraint. Okay, so let's actually test this first. Let's test this single part. Input dot update is, I don't know why I can't find this method. No on type input up. I swear there's been like a bug in Rust Analyzer recently that is fucking me over in these. Okay. In update is correct. I guess we'll do 0 is correct. And 1 is correct. And 2 is correct. Okay, apparently it doesn't think that input 0 is correct. So let's figure out what's going wrong there. Let's print out the constraint that it fails on. So I'm going to say is position pause left page. Okay, right, so okay, so let's see what this gets us. See where it's failing. Okay, the constraint 4753 is violated. That doesn't seem correct to me. It seems like that should be right, so I guess we just got something the wrong way around. Page right. Oh, of course, yeah. Right should come after left. It should be higher. I meant to put here, if it is less than. Nice. Okay. Seems to be working. So let's change this to be 3, 4, 5. Okay. Well, this all seems correct. So let's build this little function here then. Updates in correct order. So this would simply be for every item. So O2 self dot updates dot len update is correct. Expected one argument. Oh, this should be a filter. What's the problem here? Expected. Okay. All seems to be passing. So then solving Q1 becomes easy. We just need to say for every update in the right order. So for self.updates iter.enumerate, we're going to filter to map filter, not to filter map, I mean. So we take in the update number and the update itself. I'm going to say if updates, I guess we can just use this. Update is correct. Then we're going to get the middle update, the middle page in the update. So that would be updates I. And how do I get the middle of a vec? We take the length and divide it by 2. Otherwise, none. And then we're going to take, I think we said the sum of all of those. To find middle page, adding these numbers together gives 143. Okay. We can replace this with update. This should not be the length of the update, this should be the length of this particular update. Okay, so let's see if we solve Q1 correctly. And yeah, we never ended up using this. Well, we used it in the test, so we'll only compile this if we're running tests. There we go. So now this code will only compile if we're running unit tests. Okay, and we said the answer to this all should be import.solve Q1 should be 143. Was that right? 143, yeah. Cool. Well, let's see what the actual answer is for this. Oh yeah, we can remove those print lines. And we can, I guess we've got some other debug. Where is it getting that annoying print line from? Oh, yeah, there. Okay, let's run it and submit. That's the right answer. Nice. First time, all you need, one shot kill. Okay, what do you think, Leo? You proud of me? So now we have to do this, just because of the way this works. We have to remove the puzzle file and the input file, and then we'll rerun AOC download. Okay, let's just push up what we've got so far. Day 5, part 1. G push alias get to G because I type it all the fucking time and life's too short to type IT. Okay. I'm feeling really good about this solution. I think it's going to be pretty fast. It's an ON solution. It's going to be relatively efficient. In fact, yeah, let's do a little Hyperfine. Hyperfine is a little CLI benchmarking tool. And we can see exactly how fast it is. 3.4 milliseconds. That's pretty good in my opinion. I'm sure there's a bit of something we can do to make it a bit faster, but that's fine. Okay, yeah, puzzle 2. Part 2. While the elves get to work, you have a little time to fix the rest of them. Okay, for each of the incorrectly updates, use the page ordering rules to put the page numbers in the right order. For the above example, here are the 3 incorrectly ordered updates and their correct orderings. Okay, that's interesting. Okay. Find the updates which are not in the correct order, fix the order, and then add up the middle page numbers. Interesting. Very interesting. Okay, let's just put the boilerplate in place. Okay, we're gonna parse this, we're gonna solve it, and the answer should be, the answer will be 123. Okay, and it's not gonna work for now, that's fine. Let's only run this one test. Okay, cool, so how do we, given a list of pages, how do we make sure, like, construct them in the right order? Well, one thing we could do is do a topographical ordering, where basically we take all the constraints and we figure out which page only ever appears on the left-hand side of a constraint. That page must be first. Or we could go through all the constraints and kind of like, yeah, I think we should go through all the constraints and build up an ordering from them. So, you know, we have constraints like these, and we go through them and we figure out in what order. Yeah, we basically construct, well, this is my first thought at least, is we go through these constraints and we build up a directed acyclic graph where there's an edge from node A to node B. If node A is on the left-hand side of one of these constraints, and node B is on the right-hand side. And then we can do a topographical search through that graph. Basically, we start at a node with no incoming edges, and then that must be the first page. And then we pop it off, and we remove any edges going out of it, and then whatever is left with no incoming edges must be the second page. And then we remove that and its outgoing edges, and so on and so forth until we have a list of all the pages in order. But that might be a bit too complicated. I don't know. I can't really see them giving us like graph algorithms on day 5. Maybe there's an easier way. Maybe we can just, swap pages. If you violate the order on a given, what if we like repair it in place, where whenever you find a violation, you then like swap a page back. And then you rerun it. I think the most efficient thing would be the topological ordering, but especially because we only have to do that once, right? Because all the constraints apply to all the updates. So we kind of process the constraints when we first parse the input into a graph, and then we do a topological search through the graph. But I would really like to go back to work in 15 minutes. So I'm going to be a little bit biased here and just look for an easier solution than that. Oh, good day, David. So yeah, we have this like little choice here where I kind of want to get this done quickly. I'm okay if it takes a little bit of time to do. And honestly, the input isn't really that big, is it? How many constraints do we have? We've got okay, we have like 1,000 constraints, and then we have like 200 or so updates. But the pages, like the updates themselves are very small. They are each like less than 50 characters, or 50 pages. Yeah, they're like 22 pages each at most. So even if an ON squared algorithm, if it's ON squared in like the length of the update, it's going to be very small n. If we're doing something that was ON about on the constraints, that would be painful. Actually, I think we could just reuse a sorting algorithm here, right? We can have a special sorting algorithm where, in Rust you have this like sort by key, where you can say, you can kind of give a custom sorting order. So it's not just sort, these numbers in the normal kind of 0 through to 999 ordering. You would be instead sorting them based on the constraints. So if we can use this to like pre-process all of these constraints into a quick check to say which constraint, to say like if given all these constraints, number A should appear before or after number B, then we can just use Rust's sort by key. I think I like that one. Yeah, so the question is now, how do we transform this list of constraints into like a single data structure? And also we can then retrofit our Q1 part to use it. And then we could Q1 would just become check if it's sorted by key. There's a new method in the Rust library for is sorted by key. So I think I like that. So how do we consume these constraints and put them into a data structure which lets us quickly query if a number on the left has to come before a number on the right? And I think that I don't know. Well, given that I have like 12 minutes, maybe we'll just do the naive way. So given you have like all these numbers, how can we even inefficiently query this to find out if the left number, the given two numbers, if they are sorted correctly? Like we're given all these constraints. We want to create like a total or create an ordering from them, basically. I mean, again, I'm kind of thinking, you could put them all into a graph, and then left appears. If there's an edge from node A to node B, then there's going to be then A has to appear before B. And you can really easily query that data structure, but you could also just get a topological ordering and alternatively, we could just could we create a sort from this? Okay, my landlord is here, so I'm gonna do this later on. Sorry, I gotta go, y'all.